Hi everyone. Today we are doing a new format, since the last one we did not release was about us trying to draw things in real time, and it didn't go fast enough to be interesting. What we did instead is we took the question, which is, spoiler alert, design the chat service or the messenger or whatnot. We did our homework, and we're going to present some designs and talk about them. With no further delay, Julia, it's on you.
So I designed as the following. So I found out the functional requirements, which is the following. What we need to do, we need to see the contact list when we open the messenger. And also I need to see user status. I mean, whether it is online or offline. If it's offline, when it was last time was online. View my message history, send message, and another option, it's a message status distribution. I mean, whether it's sent, received, or read. So I define the following API, and it is pretty simple. It's like I can get the contact list by the user ID, and it will return this list of users.
Sorry. Do we need to open your diagram ourselves, or you will share it?
Oh, I thought you will share it.
What's the best way to do it? If you click the URL, you should see Julia's mouse.
Yeah, but in terms for video, as for future viewers, do we want to see our diagram?
I'm recording full screen, and I have already alt tapped into that, so that should be fine.
Oh, I see.
And for the record, Victor's mouse is there too.
Okay, then where is a link to your diagram in our chat?
It's in Slack.
It's like I don't see.
It's in the channel.
Oh, I did. Yes. Sorry. Found.
Sorry. No worries at all. Everybody in there? All right.
Okay, I'll continue. So I stop on the API part. On the call, as I opened my messenger, I want to see my contact list and the API function which will be responsible for it is get contact list, and also I need status, user status, and messages, get my message history, and here as we can have lots of messages, it's like I was doing like some sort of pagination that we need to introduce here. Start from what message we need to start, and limit how many messages do we need, because it's like different screen size. So also we need to send message, and it can return some status like it is sent or maybe failed, and update.
So that's the API between the user and the load balancer, right?
Yeah. And the interesting thing here, it's like how user status will be maintained, and I defined it like the user of the messages, the application which we wrote will like send update, for example, for every minute. I'm alive to our service, to this main service, and this main service will update user status. So I will touch this part more precisely a little later. And what about data model? I defined three important entities here. What we need user, we need message, and we need status of the user. And it is questionable what a relational or not relational database, but I would prefer non-relational, because if it's a messenger and we need a high read throughput, like it will be a lot of reads, and I think it should be some sort of non-relational database. And as for that, what?
Go ahead. I was just about to say that I think we are better off talking about the whole design altogether, and then in the conversation after that, we'll tackle the database question for sure.
Oh yeah, sure. Then you can see on the diagram which I defined. So it looks as the following: it has a client and which connect to the load balancers, and the main logic of the application is introduced in main service, which you may see, and it is scaled, of course, and all data like user and message is stored in the main database. And I would prefer the following design. I separated user status in the another database, but we still keep it in the main database. But if we have like a lot of users, and it's worth noting that it will be write heavy. We will update the status of the users like every minute and so, and this data is not critical because user and message is a critical data which we can't lose. And as for status, if you lose it, it's okay because it will overwritten.
Okay, so we have the user status database, which is, as you're suggesting, it can be in memory because it's not critical and it's really heavy, really write heavy. And then we have what is called the main database, which is horizontally scalable. You suggested a NoSQL one, Cassandra or Dynamo.
Yeah.
And okay, go on. This is good so far. I like it.
Yeah, and the main logic is in main service. It's the main logic. I mean, that get contact list, get messages, send message, and the interesting part is here, is below, and it is about a message status distribution. And I suggested the following design. So when for example, user say, okay, give me the messages, this method get messages. It goes here and my service call get this message from the database and also put some, it plays roles like a producer. It produces some event to the message broker, and message state change handler acts like consumer. It gets this from this message broker and update message status. This one.
I see.
In message entity.
Okay, so pretty much the rectangular boxes, the main server and the message state change handler, are your services, right?
Yeah. Message state change handler is like a worker.
Yeah, I think a worker is a good word here. Okay. I know you have a data model to cover, which is interesting as well, but I'm pretty sure people have questions on what we have so far. I mean, I do for sure. And let's start with high-level questions. Anybody?
Dima, you mentioned that holding user statuses could be in memory, but what about scaling? Because we talked about a lot of users, and like we have a few main servers, and holding that status in memory, I think it will produce some headache. How are you going to interchange that data and so on? Because in case if this will be a database, like some key values and so on, I think it would work much better. maybe not quite bad or really easily. It would be for sure easily scaling.
So do you mean do we have problems with scaling in case of in-memory databases?
No, I'm not saying we will have. I just a note for myself, because Dima mentioned it would be better to have in memory. I just try to say that maybe not, because we are going to have a lot of servers.
Well, I will certainly defend this decision here, but I'd let Julia do it first.
So, and I'm not so familiar with memory databases and how they work, and I can't comment this about scaling. I don't know exactly how they behave when we need to scale.
Well, I guess what Maxim means is you need to scale them as you run out of memory. So let's estimate the size of the database.
Okay. So, but in which case can we be run out of the
I think
memory?
size of memory is not such a crucial issue. The case is how are we going to exchange that information among different servers? Like we have 1,000 servers.
Hold on. We need to actually define the problem. There are three things that can go wrong. There are three possible bottlenecks here.
Mm-hmm.
Your bottleneck could be network. Your bottleneck could be RAM. Your bottleneck could be CPU. So let's start from Maxim first. When you say scaling issues, which one do you think would be a bottleneck?
Network. How are you going to exchange that information quite fast?
Well, we did the math last time, and it checks. And even if it doesn't fit in terms of network, it doesn't answer the question of why can we not use an in-memory database.
No, we can, but we have a lot of message servers. So each of them should have that database. And in case...
Let's get back to the drawing board. I can see your mouse, your pointer.
My what?
So, your mouse pointer. So you can show on Julia's diagram. So you have the main server. It started.
Actually, a few of them, like we have.
Right. So when I say it started, I mean there are multiple servers like this. Now you have a user status database. By the way, Julia, when you say it's a database, an in-memory database, is it the main server or the main servers that are talking to this database, or is there something in between?
For simplicity, it could be in main service talking to this database. It could be like monolith and first, and then we could split it in the microservices and split another microservice, introduce another service here. But I'm not sure that it's necessary.
Hold this thought. It's a slightly different conversation. It doesn't really matter if it's a monolith or a bunch of microservices. The real question is, so you have multiple main servers, and in your diagram here, you have a single user status database.
Oh, you mean? But we could share this status database, and each main service, which also sharded, will connect their database and.
Right.
Depends on the user ID range.
Right. So since you can't shard it by user ID, this seems to solve all the problems. I mean, all three. Network, CPU, RAM. So back to Max. What exactly was your concern?
Okay, you're saying we can shard it. Okay, we're going to cover the whole globe. So assume we have a bunch of servers in one country and in another country. A lot of statuses change at the same time. So you need to exchange that information among all those status databases. That's my question. How are you going to do that?
Hold on. You don't. If it's sharded, you don't need to exchange them across all status databases. Each database shard then is responsible for only a subset of users.
So you
Only
mean like
range of users.
each shard for one country or so on?
No, it's more like the user ID has the last 4 bits that map to one of 16 database shards. I think that's what Julia meant.
Yes, we have like a lot
So they're
of
not
users
replicated,
and-
right? So they sharded, not replicated.
Right.
Yes.
We will tackle this later. I'm pretty sure most of us would actually have this issue raised, but the idea is that if you can afford to lose this data, and in this particular case, it's okay if one machine dies once in a while and you lose statuses or whatnot. If we can afford to lose this data, we don't need to replicate, we only need to shard, as Victor suggested. All right, let's maybe table this for now. There are a lot more things to cover.
I have a quick question. In general, can we use like subscriptions, something like a model in our API, or we limited to, well, RESTful?
That's an excellent question, and I also found it interesting that Julia, you actually used Kafka. You used Kafka between your main server instances and your worker instances, but it's the only place you have the message queue or a message bus or broker. Could you talk more about this?
So I introduced here, like I suggested asynchronous event-based method here because it's this place seems like we could put the messages here, and consumers when they need it will get it.
Consumers as in the workers in your diagram.
Yeah, it's a worker.
Right.
Worker is a consumer and main service is a producer.
So this actually makes Victor's question extremely important. So the client, the user, this human icon on the left, is talking to the load balancer, and the load balancer is only talking to the main server. So let's say there's an asynchronous operation which the main server initiates so that the worker can pick it up, and this task initiation goes through Kafka. Ultimately, the result of this task should get back to the user, to the load balancer. Does it mean that somehow... So basically the question is, how does the message state change handler, the worker, how does the worker signal to the load balancer that some data has to go back to the user?
So I separated, I return this data to the users independently from this one. So I get messages from the database and I will return it to the users, and this part is only responsible for the status update, and it will update in the database that these messages are received for it.
Oh, okay. So this is like an asynchronous, I think it's what Victor would call fire and forget. And this firing happens into the message broker. You just assume there's some asynchronous operation that has to happen. You don't really care if it happens right now or at some point later, hopefully soon. And you just don't need to wait for the result. You just return the result. You return to the user right away through the load balancer. Okay. I think this works. Well, I think the biggest question here would be, we can even table the user status database. I think the original idea could work. I think the main question here would be, how do you independently shard the main server and the main database? Because database is not really per user, it's per chat. So chats are somewhat tricky, right?
Yeah. But we could still shard it per user, but user it's not like a critical part here. We will have lots of messages.
So it's really your call. We can talk about this further right now, or we can listen. Like we can look at other people's designs so that we can have different angles from which we look at the problem space, and then we can discuss each and every design independently.
So, what should I do now?
What do you think we should do?
Maybe let's go further because it's half hour past already.
Well, you have vested interest because you're next.
Oh, I'm next. Okay.
So what do you think, Julia?
so-
Shall we?
So I only suggest that I will say my suggestion how would I do it, and they will switch. So I suggest it. I would share it by user, and then also share it other messages inside shard.
Okay.
Another shard, but
I'm
not sure about it. It's the first thing which came to my mind.
Let's prepare Maxim for further torture. And let me ask you this. If you're sharded by the user, well, the chat has at least 2 users, not to mention groups.
Oh, yeah. Yeah. That's a tricky.
Maxim sounds a bit too confident, as if he actually thought about this.
Yes, I haven't thought.
Okay, let's really switch. Thank you. We if we have time at the end, we can get back to your design. I think, in fact, I think your data model is really clean and concise. It's not clear how applicable it is to this problem, because if you want to solve it in a system design way, it's not really a bunch of relational or NoSQL databases to work with. But I think your data model is pretty clean. All right. On this note, let's do Control Tab, which I just did. Max, it's your show.
So you see my diagram and you see my cursor, yes?
Yep. Well, actually, hold on for a moment. Is everyone there?
No, I don't see it yet. What do I do?
You go to Slack and you click on the link Max posted there.
Actually, one moment, I will copy paste to general chat.
Where is the link?
Sorry, one moment.
Well,
one moment.
Don't post to general. Post it to the Meetup.
Yeah, to our today's Meetup.
Okay, got it.
Here we go. While you open it, I want to mention that actually it was hard to describe everything on a single chart, because I had a few sketches on a paper for different cases, and then mixing it in all one, I don't think it will work. So in general, I think it would be better to prepare a few of them for different cases. So I will try to explain my whole idea just on one, because I'm not quite experienced drawing all those.
Sounds good to me.
Is everybody on the same chart?
I can see 4 people here. Well, I can see 5 people.
Here.
I can see 5 people here.
I see you. Yeah. Oh yeah. Looks like everybody's here. So the idea. What's the idea? We are going to have like a messaging app, and this diagram is only about exchanging messages, because in general we will have some authorization and so on, and that one would require a separate type of communication. For example, it could be some REST service, so stateless, and this diagram is related to a stateful communication. So we have like a bunch of users and a bunch of servers. Those just serve a connection session for each user. So, for example, we want to send a message. Like we have a sender, and we have a load balancer. Load balancer is just for case to get a direct connection for available session server. So in further communication, it will not take any part. Like it just knows who is free for now. It might look that the backward communication goes through this one, but no, it's not. It's not what you think about. So for this type of communication, we're going to use WebSockets to have like instant communication. So for each user, we will have like a session server. That one has actually a connection session. Here I try to describe how a message will go. For example, that guy with mustaches is sending a message to that girl. So we connected to our session server. And also what I thought about that, like we might need a separate service for generating IDs. Maybe in case of just two guys in one chat, it's not so crucial. But for example, if we would like to extend our chat for multiple, like a group chat, that would be crucial. The only case is
it the ID for the chat, or?
Yeah, no, it's just message ID, just for generating message ID.
Oh, okay. It's just I'm lost then. If it's a message ID and you mentioned potentially more than two people in chat, do you like annotate?
For example,
Okay, go ahead.
No, I mean that if you will try to extend this model and create a group chat, then you will have a lot of users in the same chat, and you will need to produce some IDs to be like in ascending order, according to the timeline and so on.
Wait. I'm still lost. The IDs of what? Of messages?
ID of message.
But then it's independent of whether it's a two people chat or a group chat.
So okay, let it be a separate service for generating. I will describe the whole scheme, but and then let's try to discuss.
If it generates message IDs, are you saying you would like them to be in ascending order, or?
Actually, we need them in ascending order, and like assume we have like a group chat. Everybody is typing fast. At the same second, we have a lot of messages. Mm-hmm. And those guys could be connected to different session servers, and you need somehow to produce to all of them correct message ID.
Oh, interesting. So you actually design it in such a way that the load balancer connects each user to some session server, and it's entirely possible that multiple different session servers are updating the database of the actual chat or channel or whatnot, right?
Session server is not updating a database itself. It sends a message to a message queue, because to not invent, like we can try to introduce some mechanism for exchanging messages. For example, we need to know where that guy is located, or we need to produce a separate service like send a message to this guy. Then we need to check where is he online, or if he is online, on what server exactly he is online, and so on. So in this case, I think we can use like a message queue. We just send in there, and it's not like we don't worry what happens further. But further, we have a consumer for like some chat history, like a database for chat history. And another one consumer, maybe it's not quite nice described here, but what could be next? A receiver could be offline or online. In case if he is online, then his session server should be a consumer of that message from a queue. Then he will consume it and send to a receiver. But if he is offline, then we need some kind of push notification service. And there's completely other question how to design it. I don't know how all that works for mobile devices, but for example, he's offline. We put it to the servers. We got a push notification service. Then we connect to all this service, and here we have a chat history database. So we will exchange like missed information and so on. And that's pretty in general how it should work. What's more? Like I don't have database schemas.
Let me help you a little bit here. I think there are two big areas to dive into, and I think you have thought of them. It's just not there. So the first question I have is, what exactly enters the message queue?
What exactly? I Googled, and it looks like Kafka is much more faster than.
It's not about which message queue to use. It's what I'm trying to ask you is, what kinds of messages are there in this queue?
Oh, like in case of just chatting, it will be a message to somebody, like a message to this guy, message to this guy. Actually, it's a question how to partition it and how to create some scale logic. But I think
let's put this aside for now. I mean, it's tricky enough to work with Kafka on a low level, so we can end up in the weeds. So imagine you have a perfect message queue that is reliable, resilient, persistent, super precise. Single replica does all the job. If are all the messages in this queue chat messages? As in, user A sends message with the following text or message ID or both to user B.
Yes, I thought about one more case. For example, two users are on the same session service, and they looks like they don't need that session queue because user A can send directly message to user B through the same session server. But
it's just an
also
optimization, right? If you have 100 session servers, then 99% would still use the message queue. So this optimization only saves you 1%.
But anyway, at least we need to store our message in a database, and also in the future we can have some more cases, more. So I think it will be easier to exchange all those flows through this message queue. Like we produce some message, and due to our functional requirements, we can have a lot of consumers. In this simple case, we just sent a message, direct message to this guy. So yeah, for sure, it goes to our message queue.
Makes sense so far. Now, what about the online, offline status?
As for online, offline, so you can see a small database like online status. What I thought that actually we can, so as soon as we are connected to our session server, like we know that this guy is online. And I think it would be better to store that information in a separate database. And maybe produce some invent some mechanism of usually it calls the heartbeat.
Well, that's pretty much what Julie suggested, right? Same idea.
More or else, yes. Like because we can have some bad internet, we have offline, online in just few seconds and so on. So, for example, we will send some statuses each period of time, I don't know, 10 seconds. So
that's fine.
Yeah,
that's fine.
So we will store it in the database. That it could be some, I don't know, Cassandra or something else, so we can scale it easy. And yeah, for sure, like you talked about in-memory database, we can put some cache between them to speed it up. But I think in terms of a lot of servers and a lot of users, that this should work pretty fine because it will be scalable. It's quite fast enough. So
yes, what I'm trying to ask is, do those keep alive, so heartbeats or whatnot, end up in the message queue?
Sorry, what do those people what?
So you have keep alive messages, the heartbeats.
Yes.
And previously you said that message queue only contains chat messages. So the heartbeat messages do not go through Kafka. So I'm back to your diagram, and you have the online status storage in the upper right.
Yes. There are no any errors because it would produce a mess on this small diagram. So I just left it here to talk about it.
So it's just, do I get it right that it's the session server that updates this online status storage?
Yeah, it would be like a separate service. Comparing to amount of messages, those heartbeat messages would be like, that would be a much smaller area of notifications. But considering that the amount of users could be like millions, yeah, we could put a separate Kafka there, or maybe use this one, but with just other topic. This information is not quite crucial. So at first period of time, I think we can skip that and just maybe use some direct connection. In case of data losses, we can put some Kafka between there. just to make it more reliable.
Okay, in the interests of actually torturing you further, as I promised, I'm sure you can handle updates to this database.
What type of updates then?
When the user gets online or is offline, you can keep your database, the online status storage database, the one where your mouse pointer is. You can keep it up to date. But in addition to updates, in addition to writes to this database, you also have reads from it. And the reads are kind of streamed, right? Because if I'm online and 10 people have me on their chats, and then now I'm offline, those 10 people should see that I'm offline, ideally with no delay.
Like with no delay. I think that we don't actually see it quite at the same period of time, because if somebody goes offline and our server will not get heartbeat in a few seconds, then his status will be changed, and we can produce.
You're trying to make the world fit your design, and I'm saying that your design does not explain the world. If I open Telegram right now and I go online, offline, your phone, if you have me in the tops, your phone would show my icon as green, gray. There's no 30 seconds whatsoever.
No, I'm not saying about 30 seconds period of time. Yeah, for sure, it's quite long. But we can have multiple events even per 1 second. So it's also a topic for discuss what period of time to use. Maybe 2 seconds, maybe 3 seconds, but some small adequate period of time.
No, wait.
Because if you will start doing like on off like 5 times per second, I don't think it's a good user experience to see that blinking message. Like having 2 seconds delay, I think it would be enough. So in this case,
you can even have a delay of 60 seconds because delays, or like of 300 seconds, because these delays only matter when my phone dies. In practice, for all the clients, desktop, mobile, native browser, the implementation of the client can catch the event that the client goes offline and send the message. So forget timeouts. I agree with you that if I go online, offline 5 times a second, it's kind of ugly if your phone shows that 5 times a second. But I think a delay of in the order of half second sounds plausible.
Okay, regardless of the delay, yeah, you're right. We need to produce some message like the user went offline. So I think there should be another arrows with Kafka for that separate service. Like you go online, offline.
So there will be Kafka between the online status storage in a sense.
Yeah, we can copy paste this one, put here, and draw a few more lines.
I see.
Wait, oops, sorry. Oh, what happened? Copy paste this one and separate arrow, like let it be
in the other direction, right?
Color. Yeah, like here, and in case if user, like this should be actually not a database, it should be some service.
Right.
So that one, online status storage is a service, and in case if somebody went online, it will produce a message, and we will have a backward message.
Like that is my second big question. Let's get there. In your design, let's not look at online status service for now. Let's look at the key value storage chat history, the other database you have.
This one.
There is still a service in front of it, right?
Yes, it should be.
So there is a service that listens to the Kafka stream, gets the messages, and updates this key value store. But then, who else talks to this key value store?
Who else?
Actually,
well, in case
in the interest of moderation, it's going to be my last question, and from now on, I assume other people would have more questions to you too.
So there would we can have a case when I was offline. You send a few messages to me, I get back online. in this case, I need to synchronize my chat history, and there should be maybe one more service which will return missed data, missed messages for me, and that one will connect to this chat history storage and will return it to me.
Would this be done on on the session server level?
Actually, it would be done through the session server. Like a session server will send a separate message to another one. Like, let's copy paste it. Like chat history. That's like this one. It could be chat history. Chat history, and that is for a case when we need to synchronize our chat history, and this will exchange information with this one.
Makes sense.
Like our session server is just an entry point into our cluster, so all communication will go through. Maybe maybe
not quite. You have a passive load balancer. You don't consider it as part of your system. It's just a load balancer, and then you have the session server, which so far from what you described, it is a pretty sophisticated component. It's not a passive proxy or whatnot. It does some job. Or what am I missing? I'm missing, I promise, the last question, but still.
Well, session server is actually holding a live connection to a user.
Well, that's the job.
And all instant communication, like not quite proxy. That's because we are using WebSockets, so we have a live connection for a whole period of time. And to serve it, we use our session server.
To save the WebSocket connection.
To serve, WebSocket connection.
This sounds awfully similar to what we discussed with Victor.
What exactly?
Except you call this middle tier, right?
As I think his question to Julia was about like a backward communication goes through the balancer too. And I just tried to mention about it that load balancer is just load balancer. It provides like a server to which you need to connect.
Well, it's the same thing for you, right? Even though it's just a thin layer, in your case, the session server is still the entity responsible for making sure it's WebSocket all the way.
Yes.
Okay, I'm trying to get someone else ask Maxim the question.
I can ask the question. So, I mean, WebSocket itself, so as you said, like it keeps a connection between the user and the server, right? So do you need all the heartbeats to know that user is online and like to know his status? Won't it be enough just when you see the user connected, you got his connection, you can send him the messages, you see that you lost socket connection to the user is disconnected?
Actually, yes, I thought about this and why I think it's better to use a separate heartbeat process, because you could disconnect and connect quite often in some period of time. And that's just for like not keeping it updating, like some blinking message, blah, blah, blah. So that's why we will use some adequate period of time just to, just to cover those possible cases when you're going through tunnel, you lost connection, get back, lost, get back, lost, get back. So,
but then you get the data, right? You get the data from the user, and then you can implement like your logic, have to throttle or, well, decide.
Actually, maybe my solution just reinvent the wheel, because I just thought to myself that it would be better from user experience to not see this. Actually, you're right. I can just remove that separate process, because as soon as I have a live connection to a session server, I know that user is alive. So I don't need like a heartbeat in general. That one is just to cover those blinking status.
I think, and then it's like more for Dima. Like Dima, do we need a heartbeat in this case? Like, is it enough to rely on the WebSocket on off?
Well, the perfect answer I would expect is that we can have different clients that support different sets of communication channels. Some would be friendly to us. They would support some open pops up all the way to the end, in which case we can rely on their heartbeats and health checks like our socket. On the other hand, we may have a connection from Central Africa where they have a poor internet connection and we even need to have our own security protocols because they block HTTPS or whatnot, in which case it's on us to develop this protocol, in which case we have to take ownership of keep alive. And I think a good design would be able to accommodate both solutions seamlessly, in a sense that if the user from the Netherlands is talking to the user in Chad, they would not care who is who in terms of security protocols and transport layers of the last mile, right?
Yeah, makes sense.
But yeah, I think, honestly, I don't quite get this argument that we still need heartbeats because we can. I mean, if the user goes online, sends messages, reads messages, these are clear actions that, forget keep alive in terms of the transport layer. If the user does something every few seconds, you don't need to send a special keep alive. You know they are alive. It's only when they're idle is when you need to send messages or send keep alive.
Yeah, technically, I agree. Like this one could sound redundant. That was just my thoughts. Like maybe it would be better in terms of user experience. But technically, yeah, user is connected, he's online. Not connected, offline.
One more thing I often find interesting is that people mostly try to design a system from the existing blocks, and when you focus on the backend, you forget the front end. You can actually do a lot if you have extra logic on the front end to help the backend. You can have request IDs, which you do need to have. You can keep the cache of what does the session server know about which users am I tracking the online-offline status, so that if I'm suddenly reconnected to a different session server, this new session server would tell me, hey, I don't have this request ID. I don't know which users are you tracking. And the front-end logic would say, oh, certainly, here it is. So you can save a lot on traffic in throughput or whatnot, and actually in CPU and RAM of the session server by requiring the clients to comply with some protocol which you also own.
So actually, as I told, there are a lot of cases and it's hard to cover with just a single chart because we can draw some connection, disconnection process. On this one, I just try to show like a message path, but yeah, I think all those.
It's good. It's all good. I mean, your diagram is pretty clean and it explains most of the things.
No, all your like questions and notes are also correct, and I think to discuss them, how to say, like for each of the discussion, I would draw a separate diagram just to, because that's a lot of processes to keep on. Maybe on this one, which is not actually tries to cover maybe all cases.
Let's talk databases, because both you and Julia have two different databases, one of which is in memory, the other one is presumably NoSQL, horizontally scalable by some, I guess, chat ID, but it could be something else. So what do you say, Maxim? What's your database?
Well, I googled, and Facebook use HBase. Other guys like I don't remember how it's called. So usually they use Cassandra. Actually, there is some competitor to Cassandra called it's called. They actually so Cassandra runs on GVM, but those guys are written it on C++. It's called Skilla or
Stilla. Yeah, it exists.
Stilla, like Cassandra, but much faster. Yeah, it costs some money.
Is anyone else having an issue with putting HBase and Cassandra/Scilla in the same sentence?
Open source and not.
Yeah, I know that one is not open source, but as they show, like they will save you money for sure. Even in that case, they are not free because, like on some benchmark charts, they work much faster, and you need actually less servers than for Cassandra and so on.
Well, HBase is not real time to begin with.
I don't know as for HBase, because HBase runs on HDFS, and that one is, I don't think it's a good fit, maybe just for this simple case when we just send messages. Maybe if you need some, but actually Facebook use it. I don't know why.
Well, this actually is a trick question, because you can come up with a design which doesn't save messages to the database too frequently, in which case you can use a much slower database. But in order for this to make sense, you need to make sure the message is stored on more than one server, because otherwise the server can die and the message is lost.
Anyway, we need some NoSQL database, because there would be a lot of messages. Like relational database is not a case, because as soon as your table will grow, an index will grow, like the speed of reads will decrease, and also you need to scale it fast, and so on. So like some key value storage looks a good solution.
Yes, in general, but I don't think the argument you made about SQL and databases was essentially was 100% correct. You will get slower reads if you have certain kinds of indexes. It does not have to be the case. If you don't need sorted indexes and you shard your SQL database, don't get me wrong, I'm not a fan of SQL databases for these particular problems, but technically this argument does not hold true. You can have fast reads with 10x database shards.
I would say that's quite another topic, because we can try to gather all requirements for a database. But in general, and just Google a little bit, and no one use. Yeah, technically we can try to use some relational. They also could be sharded, replicated, scaled, and so on. But in terms of speed of read, they lose to NoSQL database.
Well, but the question is, how often do you need to read from this database?
How often? Hard question. How often? In terms of one-to-one chat, I don't think you need to read often. Only in case if you get back one time per day, like online. Maybe that's more a case for group chats, because a lot of people in the same chat, not all of them are online at the same time. As for one-to-one, maybe this solution is like overcomplicated.
I see your point. It's a valid point. But what I was trying to ask is, do you really need to have a one-to-one mapping between the user needs to read messages from the chat and a database request? Does this have to be one-to-one?
Oh, no. As you see in my diagram, actually messages to database go through the message queue. So it's just like there could be a huge, maybe not a huge, but some delay. For example, my message already went to you, but it's not yet stored in database. But it will be stored in database. And for example, if I went offline and get back online and I have few missed messages, then I go to database and read them. But it not goes to database and then I read them from database. No. It's a fork.
Okay. That's true. I think it's like more than half the answer I'm looking for. Anybody else?
So as you know, in Telegram, we have like those, how it's called, sign, like one sign, it was sent. then 2 signs, it's like on your device. When it's blue, so in this case, like as soon as my message get to like my queue, we have first sign. So I received it. Be sure it will be delivered. As soon as you get back online, or as soon as it was delivered on your device, like we have 2 signs, you read and so on.
Well, yeah, it's a separate conversation indeed. This one is important, but pretty hard to design. It's like the seen, unseen, online, offline status per message.
Yes. Yes.
Okay.
But like question, like why do we need to read? Well, for delivering any messages, we either deliver a message to user instantly and just save it to database, or we send it to whoever should deliver it, save it to database, and then it will be delivered from your push notification service once user online without reading it from the database.
To be honest, I don't know how exactly those push notification works. And I think even in case if you see like a bunch of missed messages in push notification area, when you get back to your actual application, it will read them from a server. I think so. Maybe I'm wrong. But in my case, there is like when a message is in a queue, there are 2 processes. One consumer will read it and send to database. Another one will read it and send to your session server, and then it will get to you. So in case if we just remove database, it also will work. As soon as our message queue, how to say, queue size will allow us to keep all those messages.
I think Victor is...
What?
Yes, Maxim, please.
Just 2 small questions. One, do you actually track if the message was completely delivered? And the second related question is, do you actually need to store the chat history if you know that the message is already delivered and is stored on the client? So,
I think you need to store it because you can try to use some other device. For example, use your phone, then you want to log in on your laptop or something else. In case of apps and database, you will lose the chat history. Maybe we can try to reinvent some process to synchronize your history with some other device, but that's a separate question. What type of communication do we need? And your first one was about, could you repeat this?
Do you store anywhere the status of the message? Yeah.
The status of whether it was delivered or not?
Delivered, yeah.
I think we need to store it in the same database, but yeah, it would be like a separate few additional arrows. So delivered, not delivered. Yeah, we need a few more arrows to mark whether a message was delivered or not.
Yeah, especially if you also add this seen, unseen status.
Delivered and seen. That's because it can be delivered, but the user didn't see it.
Yes.
I think you guys are all making the same point, but you like going in circles around it without actually nailing it. The main idea is that if the communication is happening between the servers and the users are online, the database is secondary. The chat message itself...
Yeah, it's secondary. It's just for chat history.
Okay, but then you don't need to go to the database. You can use what effectively is the cache of this chat on some server. It's a bit tricky.
Okay.
It's a bit tricky on your diagram because you have session servers and you have chat history servers that are not really sharded by users or by chats. But if you have some hard binding there or semi-hard binding there, then it's only plausible to assume that the chat history machine has the cache of messages that were passed through it in the past couple seconds or minutes or whatnot, right?
Like every cache has time to live. Let's assume you sent a message to me like a month ago.
No, I mean like look at the chat history server. I'm on your diagram.
Yes.
So you're sending me a message. You're the bearded guy. I'm the ginger girl. Let's say I'm offline. So your message to me has to end up in the key value storage. But
Yes.
whoever puts this message into the key value storage, be it the session server or the chat history I suggested to be a chat history service, in this case, it can store in its own cache in memory that there is a message to me pending me being back online. So when I'm back online, if this message was recent enough to still be in the cache, I find my way to this chat history server, and it can tell me that I've missed 5 messages, one of which is from you, without having to go to the actual key value storage, right?
Yes, you can. But then you can try to log in on your laptop, and what should happen then? Like cache is already empty because you read those messages.
Not necessarily. I don't have to remove them from the cache.
Then it would be some kind of database.
Well, it's in memory. It's ephemeral in a sense that it's not a source of truth, but it keeps the most recent data for some subset, for some shard of chats, so that it can save the database.
It could. Actually, those all cases are related more to functional requirements, whether we need to store or no or not need. Both are like, how to say, your question could produce some separate solution. It will work. My one could also work. If we don't need chat history and you will use only one device, yeah, maybe that one is redundant. But as usual, like I thought, like we have separate few devices, you can log in like in a month to another device. Here we have a chat history, synchronize, and you're done.
Okay. Well, I don't quite agree this has to do with functional requirements. I mean, it's still implementation. You can have one device, but somehow you broke a screen, got it replaced, and it's the same device which suddenly has a new device ID or whatnot. You still need to get your messages.
Yes, you need. Like you said, we can read those messages from a cache, but then will we like mark those messages as read and cache will delete them? If no, then cache will blow.
No, wait, you're making the assumption that you remove messages from cache once they are extracted from there. I was just thinking of a standard least recently used cache. You allocate however many gigabytes of RAM you would like to this cache. In fact, if you have enough chat servers, everything from the past day or so can be in those caches.
Actually, in Viber, there are cases when you send the message and in few days, they mark them as undelivered. So maybe that's the case you are trying to describe. Maybe they actually do not store them.
You're connecting function requirements with implementation again. Even if that's the case, it would be a bad decision by Viber because it would, I mean, you're an engineer, you know software is buggy. You're postulating a guess that Viber's product behavior may have to do with imperfect engineering on their side, which I am not ready to rule out. But it's still, you're trying to make an assumption on how does the product work based on a potential glitch, bug, imperfection, feature of their backend.
So I tried to think about how to say daily cases we have in some popular chats. Maybe we can reinvent absolutely other approach and absolutely redraw that chart. Yeah, we can. So yeah, I agree with you.
Okay.
We can void the database, use some cache, and it will also work.
All right. Shall we, Maxim?
Can I ask one more question? Yeah? We could actually get rid of this database because we can just backup it on client, so we can have our history and backup as a separate service. So we can always, like WhatsApp backs it up your history. And the second one, if you're in conversation with someone and one of you lost the history, you can design it so you can ask the other party to send you the messages again for the lost part. So it's less load on the server.
But
And
we could have a case when you and your body lost your phones simultaneously, and you want to get back to log in back and synchronize your history. And
you have
there's no
backup.
history.
You have backup. And,
Backup of what? Of your
of your
local
history,
chat?
yeah. And
Where?
we're still missing one more crucial part, I think. Do we store those messages in plain text, or do we somehow encrypt it?
Encryption.
It's like the most important parts here. If we want to store it on the server and it's encrypted end to end, we need also to think about the keys and all the other things. And if you store everything on client, we can kind of ignore it and treat it like just some kind of binary files or something.
Well, it's a very good question, but let's focus on design and messenger today, not design and signal. Signal protocol is a beast by itself. But thank you so much for bringing this up. I mean, it is important.
So what I want to say that both cases could be like, how to say, deserve for life, because in one you have for sure 100% guarantee that you have chat history. Another one could work in some cases, but we can reinvent a case when you will actually lose that information. So it's just a question of, do you want absolutely persistent chat history or no, or you want some trick to get it from your body, from local backup, or what else?
I think the challenge here is, let's get back to your diagram. The challenge here originates from naming. You have this key value storage chat history.
Yes.
And the word history is kind of misleading, because as Maxim says, it could be a backup. And if it's a backup, you only go there if you need to restore something that was lost, but was not supposed to be lost. In a tricky case, as we just covered, when both bodies lose their phones and stuff. Or you can call it chat database, not chat history, or chat storage, in which case you can plausibly argue that you have the cache for that in each chat history server, or chat server, I would say. In fact, in my diagram, there's a chat server. And then you could argue that, hey, the cache in my chat server does exactly what the cache for the database would do, which is the cache for the database.
Okay, let it be just chat server.
Right.
I named it chat history because it's like a history. So as soon as you send a new message, it goes to the database. So it could be a chat log, chat backup, chat history. The question is, each term will be used maybe in different cases. So history, you're supposed to read much often. Like backup, less often.
Okay. Thanks, Max. Thanks, Maxim. I'm gonna actually Control Tab once again I'm trying to. Miro doesn't let me. And we are on my design. Can you guys open it from the Slack window?
Where is the link to your design?
Oh, did I not share it? That would be embarrassing. Actually, you know what? I think I can share my screen.
Okay.
Let's do this. Can you guys see it?
Yes.
All right. So, okay, I'll try to only cover the parts which were not covered yet. So we have this demarcation line. On the left-hand side, there are users. On the right-hand side, it's the cloud. Assume the cloud case. So we have this one user with their device talking to the front end, which is somewhat in between of what you said, Max. So it's a load balancer. So I mean, compare this to your picture. It's a load balancer on the left, but then it also is a gateway and some proxy. I think gateway is the term, or middle tier is the term Victor would use. Proxy is the term I would use. So it's a piece of application logic. It's not too sophisticated, but it does stuff. As in, it can result in a single user message yielding more than one message to different services or whatnot. And yeah, like in all our designs, because we have the load balancer, between the client device and the load balancer, we use whatever protocol is available. Ideally, it's a WebSocket or other persistent connection. It doesn't have to be. I mean, we mostly want it to be push enabled so that it doesn't drain battery and it's real time. But if it's Central Africa with poor internet, actually it's I think it's wrong to say it. Central Africa has good internet. If it's some country with poor internet, you have to do it. Now, if we go further and zoom out a bit, I've mastered this frames thingy. What we have here is part of the design. On the very top, there's a pub/sub bus. As an experiment, I tried to design this system in a way that can use the unreliable pub/sub, as in it's scalable, but it's not guaranteed to deliver its best effort. Just as an exercise. I'm not saying it's the best design, it's probably the easiest one to explain. Now, I actually spent... You guys with me?
Yes.
I actually spent quite some time on this part, which is the online status service. And here's what I think about it. It's mostly going to be network bound, right? Because we have so many people going online and back offline in a second. But if we put a small, I mean, I'm kind of showing off, but why not? If you put a small proxy server here, PX, in front of it, which packs all these requests that users going online and offline, packs it into a binary format, then this online status server can be a single machine that keeps all users in RAM, even if it's 1 billion users, and you map the user to last seen timestamp, it's just a single digit gigabyte. So I've put 2 of these here, the service and hot standby, not because we actually need the hot standby. We can have a single machine and a database, but I put 2 because sometimes you would need to upgrade this server, and you don't want to wait until it's up from the database. So it's, in your terminology, it's a backup database. We only use it if both are down. And we are allowed, as we all pointed out, we are allowed to lose this data sometimes. Now, it has a pub/sub, and in my design, the load balancers on the front end side are clever-ish, in a sense that when the user knows they need to see the green or gray balloons for however many other users, they actually tell the load balancer, hey, I'm going to track the status of these 5, 10, 20, whatnot users. So this load balancer machine, so load balancers all scale horizontally. And there's no there's stickiness, but it's best effort. So the user is expected to begin with the same load balancer, but if the load balancer changes, no big deal. So the load balancer that is talking to the user is concurrently handling a number of users, like let's say 10,000. So they know the list of other users that the users on this load balancer are tracking online versus offline. So in the pub/sub above here, they subscribe to the status of these users. So what happens is that in the pub/sub, there's one channel per load balancer, which says that to which this online status service is publishing greens versus gray statuses for the users which this load balancer instance has reported to be tracking. You guys with me so far?
So do you mean you try to avoid redundant calls to actually that type of database each time? You're going just to take that info from cache? from gateway cache. And just in terms, if you like switched a load balancer, then it will populate data from that like online, offline service.
So the idea I had is that if my load balancer is down, or if whatever scaling happens, or if my IP address changes, and as a user I'm reassigned to a new load balancer, it just starts from scratch, totally from scratch. And it's going to re-request the online-offline status from the service in the upper right corner. The way the request works is that this user, this gateway, sends a message to the online-offline service that I am gateway 27, and I need you to tell me the online-offline status about these users. Not even tell me about these users. Add certain users or remove certain users from that list. Now the online-offline status service in the upper right not only keeps track of all the users that are currently online, but it also keeps track of all the lists of users that each of the load balancers gateways is tracking. Once it receives the update that, hey, I'm the load balancer 27, I need to track these new users, it immediately publishes the message to PubSub to fully onboard this new load balancer. So if I'm the user, my proxy, my load balancer died or whatnot, and I'm attached to the new one, I'm going to have to wait for another half a second or whatnot until this load balancer gets the online-offline status for a bunch of users, a subset of which is what I need. And this is going to be sent back to my device.
But as soon as you're connected to the same gateway, you just get that info from its cache. And you avoid read, online status read.
Yeah, that's true actually. This is of course true.
Because each time, anyway, you need to send like write, not write. Okay, let's name it read write. So you do write each time as soon as you get some action from a user, send message, like connected and so on. But you avoid those reads.
So when you say,
I mean that online-offline status needs to be consistent. So anyway, it needs to receive write messages. This guy is online. This guy is offline. But also we have a cache on the gateway side.
Right. So yes, when I'm online or I'm offline, the load balancer I'm talking to has to update the online status service I'm talking to. Whenever other users who are on my screen, so I need to see their status, whenever they change their status, this online status service will send a message through PubSub to all the load balancers which need to know the status. But if it's all within the same load balancer, if it's just about me, I know the load balancer knows that its cache is consistent with the online-offline status.
Okay.
That PubSub is like a cache?
Oh, it's like a
subscription.
message.
It's like,
I actually missed a question by Julia.
Am I correct that PubSub is like a cache? Or what is it?
PubSub here is, you could say it's Kafka. I was more thinking Rabbit, but it's like a pipe where you can first in, first out with customizable subscriptions. So you can send a bunch of data through it, but the clients would only receive what's meant to them. And yes, in this design, I'm actually proposing the service-wide PubSub. If it's multiple data centers, it's going to be trickier. If it's one data center, for the sake of simplicity of the explanation, I just have a PubSub bus within this data center. How to shard it between different Kafka or whatnot instances is a different conversation. Let's just assume that we have the means to open WebSocket-like connections between different modules, but also proxy messages in a sense that it's one fanned out into many. All right. Let me try to tell you about the chat server, and then there's a lot to go through in terms of assumptions we made. So, as we all know, unlike the online-offline status, the chat server cannot lose messages. So if something goes wrong, the message should be there. So what I'm suggesting is, look, the icon in the upper right is this four-sided arrow, so it's a router. The icon in the lower right is this 5 dots next to each other. It's the literal actions, or better, consistent hash and design. So what I'm going to suggest is the following. I have a bunch of chat servers, and I can scale them horizontally, as many as I want. And I'm going to try to design my system so that the source of truth for chat messages. Well, I should mention that every chat has an ID. Obviously, if it's just two people, you can derive the ID of the chat of these two people using a mathematical formula. If you want to add group chats later, you would have special kinds of IDs for group chats. So I'm going to have a bunch of chat servers, and I'm going to consistent hash all the chat IDs across these chat servers. And as we covered a few sessions ago in this distributed file system, I can have replication factor. So I can have, for example, 100 chat servers, and I could say that each chat should live on at least 7 servers. And one of them is the leader, owner of this chat. Makes sense so far, right?
So it's just for replication.
It's for consistency. It's so that if a machine dies, so let me answer this question from the other end. Because it's designed this way, in theory, I could do it without databases at all. Because it's all in memory on sufficient machines. But because I'm nice, I still use databases for persistent storage, but I'm trying to keep them isolated. So it's one database per chat server. So we don't have any issues with database scaling. We scale chat servers, and databases scale with them. So this database can be as cheap and straightforward as Postgres. So if I have 100 chat servers, and let's say a replication factor of 7, it's probably too high, but whatever. Each chat server has, if you have n chat servers, each chat server holds 7 over n chats, and is the primary destination for 1 over n chats. And because it's consistently hashed, the load balancer knows exactly where to go. And if it goes somewhere and that machine is unavailable or something has changed, the chat server will just respond with, hey, I'm not the right person for you, I'm not the right server for you, go there instead. So my load balancer / proxy / gateway is a bit smart. It doesn't do much, but it handles the routing.
Okay, wouldn't it be much cheaper to not try to have that scale, how we call it, so not to create replicas for chat in memory on different servers? Since you have a database, the chance to lose a server is quite low. And in case if it's lost, messages are just read from a database to some other server. It would take maybe, 1-2 second additional time, but it's okay for chat. But in your system will be much more responsive in terms of failure, but using much more additional resources. I read that Discord has 3 replicas per databases and so on. Like 7 is assume 7 is too much, but you will try at least to replicate the chat history to additional 2 servers, and it would require more machine. And actually, disk cost of disk is much lower.
Let's do one thing first. I'm gonna do this. In the interest of making it easier to follow, I'm going to copy paste this link into our Slack, into our Zoom chat. So now I can see you guys instead. So you're suggesting we have a centralized each database, not tied to each chat, but replication factor of 3 for the whole fleet of my Discord service, not server, right?
Like, I mean that anyway you have a database, and database is much cheaper than making replicas of expensive servers, because you would require a lot of RAM, also a lot more like CPU to handle all that bunch of information. And that's just for that case, if some server will face a failure and it will be down.
Well,
Then
yeah,
immediately you will be switched to another one.
this becomes a question of costs. If you can afford to have this horizontally scalable NoSQL database, if it's free for you or cheap for you, then what you're saying is kind of easier to articulate. You would just say, hey, Dima, in your design, just remove all those DBs. We don't care about those. Just ignore them. Instead, have a single DB, which is presumably sharded horizontally by someone else, not you. And assume that if you have lost chat messages, if all the machines that had these chat messages in memory are dead, no big deal. You just go to the database. The database will have a read-write ratio close to 1. I mean, close to a lot of writes per one read. It would be a lot more often written than read. It would have to scale. It would have to be sharded as a database itself. And it's still a backup, even though sometimes you do go there. Is this what you're trying to suggest?
Like more or less, because in your design anyway you have a database. You said that servers will be replicated and then database will be replicated too.
Well, no, hold on. It's a bit better. In my case, I don't replicate databases.
Sorry, I will return back in 1 minute. My battery is draining. I need to find a source of power. 1 moment, please.
So I'll explain the main idea. Database application is tricky and expensive and painful and whatnot. So at the same time, once you add more machines as chat servers, and you will need them because it's network bound and CPU bound, once you add more machines, they come with disk. So you can use this disk for free. You don't pay for it. And all you do there is, because you use those databases, you can potentially recover data from them, even if your server is dead or down, or the network card is down or whatnot. It's just an extra layer of security. Now that I think about it, I think Maxim is right. We can afford to just not have databases there, with a replication factor of 7 of chats in memory. Oh, actually, wait. There's a huge use case of why it's important. There's a huge use case of why it's important. It's scrolling chat history all the way back into the past. Welcome back. So there are 2 use cases. There's one use case. You're pretty dark, actually. Oh, now it's...
I'm in another room and no light.
Low resolution.
No resolution is the same.
Different room makes...
No, just you.
Low light.
I
will fix it 1 moment.
It was actually possible to explain this issue with you by the fact that your laptop is now low battery and it's saving CPU. So your GPU is not rendering you well. Hey, good to see you.
No. Actually, it's a case of camera because it has, how to say, low. I don't know how to translate in English.
Okay, look. So, low ISO, high ISO. Okay, so look. Here's the issue. Most people don't scroll their chats back. Since we can scale chat servers horizontally, we can have enough of them so that every single message that is on the screen for all of us is in memory of those chat servers. Not to mention there is history on the client side, so even if you scroll back a little bit, you don't need to go to the server. So now the question is, what happens if you wouldn't like to scroll back like a year? So you scroll and scroll and scroll, and as you know, in most messengers, what would happen is at some point you hit some local cache. So one of the page up is slower because it needs to fetch the data from the backup, and then you get another bunch of messages. You scroll through them, and then again you hit the next roadblock, and it's another slower page up. We've all seen this, right?
You have some delay about 1 second since the data will be read from database. Like you'll have some. Here is your next month of data. Scroll more.
So my point is, the chat server can store the last screen or the last 100 messages per each chat in memory.
But that's like a hot and cold data. Usually you need hot data, and that's like last messages. The case for cold data is quite rare. And even if you need it, okay, please wait for 1 or 2 seconds more. But if it's a quite usable feature, everyone is scrolling a lot here, back and forward, then your case is better.
Well, actually, I think, honestly, our ideas are pretty similar. All I'm saying is that if I'm already doing sharding, and I'm doing it using consistent hashing, so I can trust my sharding. If I can trust my sharding, I don't need to trust any other sharding, which would be database sharding. If I design it from scratch, if it's my own system and it's 1999, I would do it this way. Today, if you're an expert in the cloud provider we're working with, be it Amazon, Google, Microsoft, or whatnot, you would say, hey, I have this wonderful key value store that scales horizontally and it's owned, operated by the servers, and it's cheap. I would say, sure, you don't need any Postgres, you don't need any local store. If a lot of machines die, so you need to restore data from database, or if one user is scrolling two-way to the past, we just rely on the database, the cloud database that is maintained for us. We rely on this database to get us to get us those chat messages without affecting other users. That's perfectly fine with me.
I just recently saw prices for machines in Amazon, and they were just actually I was trying to find like a network bandwidth for different machines, and machines having more network bandwidth, like they have a lot of CPU and a lot of RAM, and they cost just insane amount of money. And like when you said we will have replicas with like for 7 more servers, so it's a huge amount of money. Like, but disk is much cheaper.
Well, we covered this in one of the last conversations. I think it was the off-the-record conversation. It depends on what are you optimizing for. If you are a good engineer on a high level, you are expected to be able to estimate costs, but then there are at least 3 different company scales for which different solutions are perfect. If you are WhatsApp, you are trying to run as cheaply as possible, and you have your own hardware. So you buy expensive machines because they pay off for themselves. If you're a startup, you probably have tons of free Amazon credits, dollars, or whatnot. So you can put as many of those as you wish. And if you have to pitch your investors, you need more money for hardware, it's actually a good story. And if you're interviewing for a medium-sized company, the plausible idea is to explain them a solution that kind of works, even though it might not be optimal, because oftentimes they will go forward with suboptimal solutions, as the engineers there are also suboptimal. It's in a good way. They would rather have a solution that is easy to maintain compared to a solution that is 1.5 times or even 3 times cheaper. And we shouldn't blame them for that. Makes perfect sense.
Okay, as for me, these are just two different approaches, regardless whether you need simultaneous switching from like one server went offline, you're just instantly switch to other one. But as case for, in terms of like one question is price. We could be in cloud or we can be on our hardware, but even though we need to scale it, for example, you are expecting your users will grow quite fast, so you need more servers. And even though with your approach, I think you would require more. But am I right that you're saying that scaling database is too more tricky than scaling servers like in your hashing approach?
No, I totally admit it's just my fetish. If I can avoid scaling the database, I'd rather avoid it. I don't want to have to become an expert on how does a particular database provider scale horizontally. I don't want to wake up at night because something is overloaded and then have to figure out what the hell is going on because their sardine sucked. I'd much rather know exactly that I have 100 chat servers with, 100 gigabytes database per chat server, and if something goes wrong, I know exactly and beforehand what and where went wrong. But I mean, I'm kind of old school here. I'm not advertising this to be the right answer, especially in a casual conversation or interview setting. It's just how I would do it.
Okay, let's think about Telegram. User base is just huge, and we all have our messages on all devices, so for sure they use database. Yeah, it's encrypted, I guess, and so on, but I don't know what messenger does not use database.
Well, actually, once you become large enough, you have 3 tiers of data storage. You have in-memory, have your local database, and you have a real backup, like backup, which is tape.
Tape, yes.
So I don't think it's plausible to design the system in a way that 0.0001% of user requests has to go to tape. But I would not be surprised if Telegram just has a product decision that chats that are over 1 year old don't have to be available except on tape. So they would be able to get those chats if it's like court order or something. But in terms of product access, you just don't have access to them. They would probably be in the cache. That's how it usually works. But I would not be surprised if there's a product decision that says we do not guarantee you can access your chats beyond 1 year mark.
I don't know.
Well, I mean, on the other hand, now when I think about it, it's still not too much data. Even the chats for all time histories are still a drop in the ocean of media content. A picture is worth a few million words.
Actually, pictures, videos, and so on. Time by time, I clear cache of my Viber and Telegram, and few groups of Viber produce just a few gigs of rubbish per month. So it's just from a single user. Just imagine all those millions of them have the same. So you need to store it all on server.
So I have a design suggestion there. Beyond some mark, let's say beyond 1 year mark, we just get the chat history, we splice it into 1 month periods, we convert each 1 month period into a tar.gz archive, and we store it as a piece of multimedia. And then if we need to read these messages, we just access our CDN for that piece of multimedia and extract it and store it in the cache of the machine that is responsible for accessing those messages.
We just send you a zip archive on a CD drive.
No, it's what the chat
here are your messages.
It's what the chat server would do for you. But yes, if it's in Europe and you have the law, and there's a law that you can request all your data, and you request all your data, and it's more than a year, then you will get a CD drive. Yes, you do get a CD drive in this case, which will contain a bunch of text files with your messages, a bunch of directories with your media content, and a single directory with tar.gzs of your messages grouped by month beyond the 1 year mark. Something like that. Why not? Okay, since there are no more questions here, before we're too tired, let me walk you through a couple of things I wrote in that diagram because I think they would shed some light.
Can you share it again, because it requires access?
Okay. Yeah.
For us to.
No worries.
Did you share it? I don't see any links.
There's the URL, but we don't have permission, so it's better like this.
It's okay. Here we are.
But your URL in which chat? Today's meetup?
In Zoom's chat. I could try to change the privacy of this board, but it's too late. My bad. So I have this frame with the ideas that were put into this design. So obviously, as we all discussed, the internal communication is all PubSub based. The external one, the one on the very left of this, so this guy, this link between this and this, we hope it can be PubSub like WebSockets. We don't have to keep it this way. We can support all devices, all countries, all restrictions or whatnot. Everything is push interface, unless we have to use pull. One thing we have to talk about is Importancy. So since in this particular problem, every single event that takes place in the system is initiated by a human being with their device, we can design the protocol so that every single time I write a message and send a message, the device I use to send this message generates a unique random request ID, so that at least we don't send this message twice. You know, like it happens in Facebook. You're on a train, the connection is going on and off. You write a comment, you click post, and then once you're out of the tunnel, you see 3 comments. It's because they don't have request IDs. It's a bad idea. You have to have request IDs because they let you resubmit the same content and not fear duplication. And you should carry this request ID all over. So for example, in this particular case, if you're in the tunnel and you send a message with a request ID to the load balancer, somehow this load balancer talks to a chat server which is down or whatnot. It goes to a different chat server. It can still resolve the message as being a duplicate because it may have received it elsewhere. Makes sense so far, right?
But you mean that that message ID will be generated on your device?
Yes.
Mm-hmm. Okay.
All right, now on the status server idea, since we can lose updates, wondering if you can see my cursor. Yeah. So since we can lose the updates, we can keep them in the memory of one server. So I know it's kind of controversial. We don't have to. I just think RAM is cheap in this case. So even 1 billion users mapped to a timestamp, or even the, I don't know, geolocation or whatnot, it still fits in memory. In order to do this effectively, we have to realize that the bottleneck is going to be network. That's critical. So like in this design, this pipe, this channel from the load balancer to this upper proxy server, if it's JSONs, it's going to be overloaded. So yes, I can put some logic on the load balancer. As we discussed before with heartbeats, I don't need to send heartbeats unless there's no activity, right? So this can be done by the load balancer. Extra heartbeat, no big deal. But so let's say only what has to be sent goes here. But if it's JSONs or even anyhow not packed text messages, this traffic would be huge. So what this PX server here does, this small arrow here internally, is the binary protocol. Let's say if the user ID is 64 bits, so it's 8 bytes. I have like 24 bytes of 32 bytes blobs, which is user, timestamp, and some request ID or whatnot. I don't even think we need those. This way, the traffic to this online status service is, not to say small, but it certainly fits a single network connection. And this guy is just distribute a local hash map or even local array. You don't need a hash map. It's a fixed set of users. Oh my god. This guy, long press to unlock. What's it supposed to mean? Okay, I can't select it. So this guy just keeps an array, bolsters. Hot standby, we discussed that. Back to here. The database there is not entirely necessary, as we discussed, until these machines die, in which case we can afford delay, like interruption of this subservice. If all the users of my messenger don't see statuses for 30 seconds worldwide, no big deal. And 2 machines is because I want to make sure that I can update the version of one of them and then the other. Because if I don't have a hot standby, then I'll have this 30 seconds blackout for the whole planet. Every single time I have a new version. This way I can flip them. And yes, the PubSub is the global PubSub for the whole thingy. And these machines, these online status server machines, these guys, they hop up publish that directly. It's still not too much load. We could do it through a different proxy or the same proxy if it's network bound, but I don't think it's the case, to be honest. Now the tricky part is this paragraph. It's mostly what we stumbled upon the last time and talked about yesterday. So each user device sends the load balancers to track, and it assumes that the load balancer, so there's stickiness, right? The user device is assumed to be talking to the same load balancer. It doesn't have to be the case. They can be reassigned. That's normal. The state is ephemeral, but in 99.9 something% of cases, I'm going to be talking to the same load balancer. So the same load balancer knows the list of other users whose online status I need to see. So the updates are only incremental. Please track this user. Please stop tracking that user. The request from the device to this load balancer is I device X with the request ID Y would like to add the user Z into the tracking list, and my previous request ID is K. So if it's the same load balancer, it knows my previous request ID for the previous map. Then right away it can just update it with a single record, with a single user editor removed, and super quick, super fast, no network overhead. If somehow anything was lost, maybe the previous request was lost, or maybe it's a different load balancer, the response of this device is just, hey, sorry, I lost the list. Please send the whole thing. And the device sends the whole thing. So it's incremental because I have request ID in previous request ID. And it's still ephemeral because if all load balancers die, nothing really happens. They just need to repopulate their lists. You guys with me so far?
Yes, but as you were too precise to my naming, I would try to be the same way. Why do you say gateway and you try load balancer and you try to put in there some additional logic for tracking who's online? Actually, it should be a load balancer. What you're saying about is more looks like for a proxy. In that case, I think it would be okay, but it's like about single responsibility. You're trying to put more responsibility in that load balancer. It just need to say connect there or connect there.
So if we go with your design here, what you're saying is that I may well have session servers on the right hand side. I think you guys can see my screen, so I can have these guys.
Yes.
And these guys. And this would be a simple load balancer. All it does is SSL termination, HTTPS termination, and waterfall routing with stickiness. That's fine with me. It's a good point. I did not have to outsmart myself here. It's perfectly fine for these to just be a load balancer, and this stack of services to be like somewhere. I'll try to draw it right now. It would be somewhere here, right? Is this what you're suggesting?
No, looks like a load balancer should be in the first square, but in that one you should put all that logic for getting online, offline, and it's like a proxy.
Oh, I see. So what you're saying is that this is the Amazon load balancer, which see, it's really hard to use this. This is a load balancer, and this is technically the application server, which is the gateway, right?
Yeah, or like this.
Okay, that's fine. And this should be page up. Well, yeah, I think we can live with this. Good suggestion. See, I'm outsmarting myself again. Famous for this. Okay, back to assumptions. Let's skip this part. Go all the way here. For the chat server data, I suggest we use, as I said, consistent hashing, and the leader chat server, so chat IDs between two people, order of one mathematical formula, group chats, special service. And then, yeah, I even say debatable here. But I would suggest one database per chat server. We discussed why it may not be the best idea. And the important part is that, same as with statuses, it's even easier, in fact, to explain request IDs from this part. So we have request IDs to keep history of them. So the message from the device to the application server, that is, the message from the device to here to send a new message is, this is me device, this is my new message body, this is the request ID I generated for it, and I would like this message to be appended right after the previous message, for which I may have either the message ID, if it's already populated fully back and forth, or the request ID from the same device. If I do it this way, I would know where to place the message in the list. So this way, if in the meantime different chat servers are going up and down, maybe we're adding 100 machines because system hash is being reshuffled and stuff and all that stuff, even if messages get synchronized from memory or from database or from the backup in random order or whatnot, we still can reconstruct them in the order they should be. You guys following?
Or less, yes. I have a question. So in general, your architecture is trying to be quite effective in terms of resource usage. But since you're going to generate a message ID on a device, what data type are you going to use? Because it should be compact, but also it should be somehow incremental. But since it's on your device ID, for example, you send message today, you send message tomorrow, then you can send message from other device. So how are you going to track that? Or it will be just a separate pair of data like device ID, message ID, or it will be a general message, global message ID per this chat? I think we can use some UID. It took a lot of space and it works. It just works. But since all of that is so optimized, we don't want to use some blown up data structure.
Well, so clearly not UUID. The first instinct is to say I would use uint 128, although in practice uint 64 would probably do. The important part of this question you're asking is, remember we talked about in your design that you wanted the message IDs to be monotonic. As in,
to be what?
You wanted the order of message IDs. If you sort messages by message ID in certain chat, you want them to be in an increasing order. If message B came after message A, you suggested that the message ID of message B must be after the message ID of message A. Yes. If I heard you right. So this is actually not a bad idea at all. It's possible to do it this way. The painful part here, I mean, yes, we come from different universes. The painful part here is clock synchronization. You probably don't want to use client-side clock because client-side clock is, well, never reliable. You could say that, hey, the chat server or even the load balancer or the gateway that receives this message, I have this however many bits, let's say 128 bits for a message ID. Somewhere in the beginning of it, I would say, hey, this part is going to be timestamp, Unix timestamp, which is a great idea. It works really well until the part where two messages come really close to one another and your clocks are not synchronized. In practice, for user level, like for messengers where the messages are user generated messages, it's pretty easy to synchronize clocks to the accuracy that is far beyond what's needed for you to not be able to send two messages this quickly. I mean, you can't send twice this quickly. In the systems I design, this can be critical. That's probably why I have this brain damage towards being safe. So my argument is that it is intuitively a good idea to make sure that the messages ID mimic the natural order of time. If you can afford to have enough bits per message ID, it's even a good idea to make sure this message ID has timestamp encrypted in that, encoded in that, so you know which bits to look at in this message ID to know exactly like which second of the universe was it sent. That's a good idea. How important is it in practice? In this particular case, I don't know. I don't think it's that important, in the sense that I believe that if you have a perfect or good enough design for the chat, for the messenger service with this restriction, and they have a second perfect design without this restriction, they would not be different in their ultimate quality. But it still is a good idea. I like it.
So there could be a case like for a message history, for example, I sent few messages, but I was offline. Then you send few messages and you see them. Then I get back online. So my messages should appear before your, and you can just unseen them. So
That's
your screen
important.
shows only your last message. So maybe that's not quite a case because they just appear as the last one. They should appear as the last one.
That's an
So-
important product question. If I were designing this, I would say that it's a strict requirement that if we message each other and we're in different parts of the world, and then half a year later we compare phones, so we look like we're next to one another and we're looking at our phones, I would expect the order of messages to be identical on our phones. I don't think this is the case in modern messengers. In fact, I've seen messages being misordered.
Yeah. I mean, it should be a case, but you said we can put a timestamp into a message ID.
I have to
And
step
I
out.
mean, like you. Sorry, what?
Sorry, keep going.
Go ahead.
Oh. So timestamping is in a message ID, but you were offline. Now your message is delivered, but there are already some new messages. So looks like your messages from offline status should appear in like historically before your current messages. And they could be just unseen because your screen is busy with your messages. My appeared, they has a timestamp in ID, so it should be ordered according to timestamp.
Well,
And
yeah,
you just can see them.
Technically, because the messages can be reordered, and we know that, it already proves that your idea of message IDs reflecting time is not implemented in Telegram and WhatsApp, at least. Interestingly. Otherwise, they would not have this issue, right?
Yes.
Are you sure it's an issue? Because really, you usually want to see the new messages at the bottom to not miss them. So I'm not sure that it's actually a good thing to put them somewhere up so user can see it.
Agree. That's another good point.
Okay, then how are we going to?
So we do not have a proof they don't use time reflecting IDs.
Maybe they have, but so imagine you sending message to me, I send to you. Both other devices put like message ID locally, sent to the server. But on a server, they should be ordered, and according to time, they will get to the server. So server need to add a timestamp to this ID, and then it looks like.
Yeah. If we all agree that time discrepancy on the server does not hurt us, which it really does not in the messenger case, I like your idea. I would go this way. In fact, I think there's an even better way to there's a better product use case that explains it. Screw messaging between you and me. Let's say I'm talking to you on Telegram, but I have Telegram open on 3 devices, which is pretty normal. So I have my laptop with the chat with you, I have my phone with the chat with you, and I have my iPad next to me. In theory, I could begin the message on a desktop. It needs a URL to be pasted there, so I go to the browser and the message is still in the drafts. At the same time, I'm texting you from my phone to answering your quick questions, and then at some point I simultaneously press send on the phone and on the computer. In this particular case, I think what the other Maxim Losev's suggestion is that in this particular case, it is more important for the unread messages to be down there, and it is less important that their order is fixed. And I think it's a really valid point. I mean, I would still argue that you can still sort the unread messages. Like you can put unread below read, but you can still sort unread by this server stamped timestamp.
Yeah, what I'm trying to say that I think anyway, timestamp should be added on the server side, because if you will log in on a new device, you will get all those bunch of messages. And how are you going to keep the order on them?
Okay, so that's
by some ID.
It's a third question. Forget order. We do need timestamps on messages because timestamp is part of the message. In most modern chats, I think even in ICQ back then, there would be message text and a timestamp. And a timestamp clearly is coming from the server. Now the real question is, where do we store this timestamp? Is it like an extra column in the messages table? Or is it extractable from the message ID? And what you are suggesting is that, hey guys, if message ID is large enough, so let's say 128 bits, then we don't really give a shit about an extra column in the database or whatnot that stores message timestamp. We can just have a function that maps message ID to its timestamp down to a split second. And I think it's a good idea. I see no reason not to do it. In fact, if I would design in WhatsApp today, I would use this approach.
Let's find what they do.
Yeah, I mean, message IDs are visible. I'm not sure about Signal, but in Telegram, WhatsApp, and whatnot, you can just find out message IDs. So if you really are curious, I urge you to set an experiment.
Okay.
With this being said, I had one more important thing to cover. Well, anyways, any more questions, topics, suggestions?
Looks like no.
Oh yeah, so this is the one thing to cover. When I was hosting a course on system design, we went through Grokin a number of times, and I mean, I could be wrong. I'm not claiming authority here, but in a few places, the Grokin solutions introduce a component which is called I forgot the exact name, but it's the ID generator. The idea being, in order for the IDs to be different, we have a special component that just generates different IDs. And so if we don't have the timestamp and guarantee requirement, then I quite frankly don't see the need for that component. You can just have more bits and have random IDs. They would not collide. And UINT64s don't collide randomly. I mean, if you have UINT64 and you put timestamp there and maybe the source user ID, and you also encode the number of the gateway servers that had this message originated from, in this case you need more bits, but 128 bits would be more than enough. So I don't quite see the need for this ID server. There are two reasons you may need the ID server. One is that you really want to squeeze everything into a small number of bits. I mean, if you're out of bits in 64 bits, and the next step would require doubling your key size, and that's a lot of RAM to use, I would understand that. That makes sense. And the other idea is what you suggested with the timestamps. Because if you have a server that gives you these IDs, then you can guarantee that the next ID, then since everything goes through the servers, it can guarantee the order of messages. And stamp timestamps, which would always be comparable to one another, because they're from the same universe, stamped by the same server.
Actually, I saw some piece of information like Twitter had a separate service for ID generation. Then it was So the article was about 2010. Then after a few years, they started a separate solution for that one, and it was more complex. But in fact, they had like a whole solid service for just ID generation. There was some article. I didn't read it whole that article, but like the purpose was for properly sorted IDs and blah blah blah.
Well, I mean, it's one of the canonical problems in computer science, especially when you have real-time data flows. How do you serialize them, as in how do you stamp indexes on them in a reliable way? And if they all can go through a single machine, and if this machine is indestructible, and the network to it is guaranteed to be up and running, it's an easy problem. Once you do need to guarantee that number n is 1, 2, 3, and exactly 4, 5, 6, even if the machine dies after 3 and before 4, it's a really hard problem. But again, I mean, I might be wrong, but if you can allow for those gaps, you don't need a lot of sophistication here.
But do we need any sophistication here? We can always especially if the messages are encrypted and they use the last message as key. So you can always reference last messages after which you apply the next one and order them by that. And you don't need complicated IDs for that.
Well, yes, Signal does that. But then you go back to the realm of problems where you have two devices from which I'm sending messages concurrently. I don't think Signal allows that, for the record.
Signal uses like WhatsApp thin client to the phone, so you can also open it on desktop, and it will be a thin client to your own device. So it's like the same device, basically.
Oh, right. It's a thin client, so I cannot have it installed on two devices and have these two devices connect to different wireless networks and speak from them. Yeah. So they cheated to make this problem solvable for themselves, but they would have the same problem as you suggested with because they have to. Well, so two things. One is Signal is encryption first. I don't know much about their protocol, but I read the white paper, and I've spoken with people who kind of have to do with that. They are doing something really, really sophisticated. As in, if you somehow get the encryption key for one message, because you can read the memory of the device, you would still not decrypt more than like 1 or 2 messages above and below. They are doing something really, really sneaky.
They rehash the key for every next messages. Right. They rekey it again and again. So it's
right. So I'm no expert here, but the point is, with Signal, you do have a fixed order of messages. In which case, this problem of you have read messages and then unread messages above those read messages, in Signal it's a real issue, which is a product issue, since I think both you and the other Maxim outlined this issue 20 minutes ago. Well, I don't have a good answer to how to solve it. All I'm trying to say is that messaging where messages originate from humans is somewhat easy because we don't have to worry about sub-millisecond delays. Designing the message bus for high-frequency traded asset would be a different problem. It's going to have a lot of similar components, but it's going to have different constraints. And I guess I just did my best to outline those. Possibly over-engineering the very messenger in my own diagram. But I hope you did enjoy it.
Anyway, each part of all those schemas could take many, many days of discussions. Like, here is the case for message ID. There is a case for some separate flow and so on. So those general charts are quite very general.
All right. Any follow-ups? Any questions while we're still here?
What topic for the next time?
That's an offline conversation.
Nice.
All right then, I'll stop it.